This is BeerSmith Podcast number 109. It's early August 2015. Adam Shake from BrewTroller.com is my guest this week to talk about electric brewing systems. Thank you to this week's sponsor, Craft Beer and Brewing Magazine. They're now offering a full 6 issues a year, up from 4 at a great discount. They're offering a new discount code now, which gives you 15% off everything they sell, including subscriptions and training. The new code is BeerSmith 2015. I encourage you to check out this great new magazine for homebrewers at beerandbrewing.com and use the offer code BeerSmith 2015 to get your 15% discount today. And also, BeerSmith Mobile. The mobile version of BeerSmith is a perfect complement to our desktop brewing software. It includes all the tools you need to create recipes on the go, share them with your friends, and act as a pocket brew timer. Check out BeerSmith Mobile at beersmith.com/mobile or on the Google Play, iTunes, or Amazon app stores. And now let's jump into this week's episode. Today on the show, Adam Shake joins me from BrewTroller.com. Adam's been brewing for more than 12 years and is currently president of the AB Normal Homebrewers Club. He's been electric brewing for more than 6 years and is the owner of Brew Troller, a brewery controller for home and craft brewers. How you doing today?
Good.
So we're going to talk a little bit about electric brewing systems today, right?
Yeah, absolutely.
So let's start first with some of the advantages of using an electric brewing system versus a conventional, gas system.
Well, I'll tell you, my favorite advantage to electric brewing is location. So I brew in the garage, but you can brew basically anywhere in the house because you don't have to worry about carbon monoxide or any of the other byproducts from combustion when using a burner, as well as it's very, very quiet. In fact, I just posted a video a few minutes ago of a brew day that I had done about a year ago to YouTube, and you can hear. The only thing you can hear in the background during the brew day is the pump running, and even that is quiet. So you don't have that rushing roar of a burner or any of those kinds of things. And then the level of control that you maintain with electric brewing is fantastic. I mean, gas burners can be controlled, and there's systems out there.
So you think it's better than a gas system as far as control goes?
I think it's better for control, and I think it's better for efficiency. And I think part of the reason it's better for control is because of the efficiency. Since that element, the thing that's doing the heating is submersed in the liquid, you're not losing any of that heat that's generated to the atmosphere. So when you turn it off, it's off. When you turn it back on, it's immediately heating at full power or whatever power it is you've set it at. So I think that level of control gives electric brewing an advantage.
I assume you can vary the current and the heating element too to make it hotter or colder, no?
There's kind of two ways to handle that. You can use vari-arcs or some of the more expensive current limiters. Those can get a little on the expensive side, and they're hard to control, especially at the homebrew level. But using a PID or power pulse width modulation, which is in essence what a PID does or what Brew Troller does, you in essence turn the element on and off rapidly in cycles that allow you to do the same thing as basically turning the voltage down in a very simplistic sense.
I know a lot of nano breweries have moved to electric too, mainly because they don't have to go through all the trouble of installing a venting system and all the code issues with installing gas.
Absolutely. In fact, a good friend of mine has been in the research phase of starting a nano brewery, and he bought some used equipment, and it's all electric. Well, at least the boil kettle and the mash tun are electric, primarily because of that. Now, it also uses burners as the primary heating source. So when you have a large volume of water, he uses a burner to heat that water. But to maintain temperature, say for mash or for step mashing or whatever, electric is great because you can use actually less power to maintain. So it's more efficient that way. And it allows you, again, that really fine level of control.
Mm-hmm. Well, there's a lot of variations of electric brewing systems, including brew-in-a-bag style systems like the Braumeister, all the way up to, full 3-vessel systems. And you can even have HERMS and HERMS systems. Can you cover a few of the variants for us?
Certainly. I think the simplest, if we want to start at the simplest, you'll see guys that are using what are called heat sticks. So they're a single element, typically just mounted to a cord with a pipe or whatever that can be used to actually submerge the element in the vessel. That you just literally plug into the wall, and it's that simple, right? You get no control in that situation. It's on or off, but you can do that on your countertop. Even some of them are done in plastic buckets. You don't even have to have a metal container necessarily, especially for the mashing side of things.
Yeah, I remember back in the old days, this is, in the late 70s, early 80s when people started brewing, a lot of them were brewing in essentially buckets with heating elements in them.
Yeah, it seems to be a lot more popular in Europe. If you talk to brewers over there, you'll see their setups with plastic buckets that look like our ale pail sitting on the counter with a heating element installed inside. So that's the simplest way. You're seeing more and more brew in a bag or single vessel setups appearing, and there's some commercial versions out that are variants on that same thing, and they're very easy to set up. It's a single vessel, one element, maybe two, depending upon how big of a batch you want to do. And then other than that, it works just like using a burner. And then I brew on a HERMS system. So it's a single tier, 3-vessel setup. I've got heating elements in the hot liquor tank and in the boil kettle. And then the mash tun, of course, holds the grain and then recirculates through the heat exchanger that's in the HERMS system. So there's more complication to that. It's definitely a more convoluted setup, but with the addition of things like, ball valves, motorized ball valves, and controlling the pumps and some of these other things that you can do with some of the more advanced controllers, they're not any more difficult to brew with than a brew in a bag, or even just that, countertop bucket with an element in it.
So here's, I'm going to bring up, this is a Braumeister. This is an image from a Braumeister, and you can see basically they have a large strainer bag, if you will, a metal bag that's in the middle for the brew in a bag style system, and then the heating element at the bottom. And I believe this thing has a recirculation pump, right?
Mm-hmm, it does. I think there's two others. I think the Pico Brew, and there's another one. I think Brew Boss, or
I know Blickman has one as well. There's several. There's a lot of them out actually. I think.
Yep, and they're all that same basic idea. You're going to add your grain, but you're going to heat the liquid with an element and just recirculate in order to maintain your temperatures during the mash. And that's that brew in a bag style of brewing is gaining popularity rapidly. It's been around for quite a while, but here in the U.S., it seems like it's just skyrocketing. That's what everyone's doing. We've got a small group of guys out here in Central Illinois that brew together on a regular basis, and I think I'm the only one left who's not brewing a bag brewing from our group. So.
Yeah, it's simpler and requires less equipment, and you can even save some time in a lot of cases. We've done a couple episodes on brewing a bag recently. Well, let's see, about a year ago, I guess was the last one.
Yeah.
But I've written quite a few articles. So we talked a little about that. I think most people are familiar with a 3-tier system, and obviously you could have a 3-tier system that's all electric, right? You'd probably have the boiler would be electric, and the mash tun would be electric, right?
Yep. Or
I'm sorry. The hot liquor tank, I should have said.
Yep. And if you did it that way, you the benefit of a 3-tier system is you avoid the need for a pump. You could gravity feed the whole thing, which would make it a little more simple in terms of setup, less equipment to purchase. But in essence, all you need to do when you're thinking about electric brewing is just replace the burner or your stove with a water heater element, and that's all you really have to think of in terms of making that jump from a gas-powered brewery to an electric-powered brewery.
Right, exactly. So, here's a simple 3-tier system I'm throwing up on the video for those of you watching the video. And then the last one, I wanted to cover RIMS and HERMS. Can you talk about RIMS and HERMS and what the difference between the two are?
Certainly. So, HERMS stands for Heat Exchange Recirculating Mash. And RIM stands for recirculating infusion mash. They're very similar. It has to do with where or how you're actually heating the liquid. So in a HERMS system, you're taking the wort out of the mash tun and you're circulating it through a coil that sits in the hot liquor tank. And so the coil is submerged in liquid, in water, and you maintain the temperature of the water, thereby maintaining the temperature of the liquid through the coil, which helps you maintain your mash temperature. Now there's an offset, you lose a little bit of temperature here and there, and those are the intricacies of it, but that's how it works. A RIMS system is slightly different in that you're recirculating through what's called a RIMS tube, which is a small, they're really not that small, but a small tube in which the heating element is inserted in the tube, and so you're actually recirculating through and past the heating element the whole time. A lot of two-vessel systems will be RIMS systems. So if you don't want to invest in or have the space for 3 kettles or a cooler and 2 kettles, you can use a RIMS system with a RIMS tube and replicate some of those same features without having to have the third vessel. There's a lot of discussion in the homebrew world about which is better. The HERMS folks will say that RIM systems suffer from scorching the wort, although I've never known anyone to actually prove to me that happens. The RIMS guys will say, well, the HERMS aren't as speedy, right? You don't tend to raise steps as quickly as with the RIMS because you're not directly heating the liquid. So there's benefits either way, but in essence, you're recirculating, which is a major benefit for both of them. It's just whether or not you're recirculating through a heat exchanger or recirculating directly past the element.
So here's a RIM system, I guess, with a heat exchanger.
Mm-hmm. Oh yeah, and there's multiple variants, hybrid variants of the two.
Right. So I mean, those are the basic systems that we could have, and as you point out, any of them could be electrically heated. So let's walk through the basic components of an electric brewing system. Let's start with the heating element.
Certainly. So the most common heating elements are water heater heating elements. So in your home, you've probably, or a lot of people, either have a gas or an electric water heater, and we're talking about the same technology here. If you have an electric water heater, inside the water heater is a coil, although some of them look like coils, some of them look like sticks, and that element gets hot. So as you run the electricity through it, through resistive electricity, it heats up. So the elements come in various sizes and various shapes, anywhere from ones that you can plug into a standard wall outlet to ones that require a whole lot more power, like a range outlet or a dryer outlet, 240 volt power. So those electric water heater ones are probably the most common. And there's variants there, including fully stainless steel elements that a lot of guys like to avoid rust. From there, you move on to some of the more advanced things like Blickman has the boil coil, which is a circular heating element designed specifically or originally to go into their kettles, but you can install them into their kettles. And then there's a number of other variants to that. But in essence, it is the same coil, the same heating element you would use in an electric water heater.
Okay. What about powering it? I know some small systems run off to regular AC, while others need 220 volts. What kind of power systems do you need for various sizes of what we would typically brew for home brewers?
Certainly. So, kind of the lowest level of element that most guys would be using is about a 1500 watt element, and a 1500 watt element is going to be relatively slow to heat up even 5 gallons of water. But the benefit for that size of an element is you can plug it into every outlet in your house. It's 110 volts, 1500 watts, and there's some calculators online that will actually let you plug in the wattage of your element and the volume of your boil, and it will tell you how long it's going to take. So you step up from there. The biggest element that you can typically get to and still use a house outlet is a 2000 watt element at 110 volts. And so you're kind of limited there. Once you step above your 110 volts into the 240 volt world, which is what your range or your dryer is plugged into, or a welder or some of those kinds of things, then you open yourself up to bigger power. So an example would be my HERMS system that has two 5500 watt, 240 volt elements in it, has 50 amps of dedicated power just for the brewery. So it's a lot of power, if you're going to go big, but it doesn't have to be. You can start small. You can power one element, one 5500 watt element, from the outlet your dryer's plugged into in most cases. So guys that want to start somewhat small and see if they want to enter that world probably have, or very, very probably have, what they need already to plug into in the house. They don't have to add anything extra.
So, but a typical regular outlet, right? We're looking at maybe 1,500 to 2,000 watts,
Yep.
which is basically 5 gallons, right?
Yeah, a 2,000 watt element would probably take. Now, I'm not 100% sure here, but probably take 20 to 30 minutes to boil 5 gallons of water.
Mm-hmm. And obviously, if you're brewing all grain, you're probably boiling a little bit more than that.
Yep. And now, if you're doing all grain, you only have to get that temperature up to mash first, and then
Right.
you're going to do your mash, and then you only have to raise from mash to boil. So you split that time a little bit in half. It's not quite in half, but it's not as bad as waiting a half an hour from cold to even starting brewing. And then there's guys that are going even bigger, 30, 40 gallons. In fact, I'm helping a friend install in a 140 gallon brew pot. It's got 4 5,500 watt elements. They're 203 volt elements, and I think he's looking at like 40 minutes to boil. So you can really step it up. I mean, you can really get big, but you got to keep adding elements. You got to keep adding power.
Right. And so you want to go much beyond 5 gallons, 19 liters, you're really looking at 220 volts, right? And
Yep.
And at 220 volts, you can go up to probably at least 15, 20 gallons?
Oh, think? Yeah.
Or more?
I think you could probably.
Well, I mean, for a typical house outlet, for example, without having to rewire the house.
Yeah. One 5,500 watt element should realistically be able to handle 20 gallons of liquid in a reasonable amount of time.
Right. Well, most of these systems have some kind of a temperature probe to maintain temperature as well, to either switch the system on and off, or as you mentioned, vary the current flow, right?
Mm-hmm. Again, the most basic one I talked about, just plug into the wall and goes. That's kind of like, that's the brute force method of brewing beer with no control. In order to maintain control, whatever it is that's controlling has to know what temperature it's at, right? So then there's a number of types of temperature probes.
Mm-hmm. What are some of the types?
There's the what are the RTD types? The Dallas 1820Bs. Those are the primary types. The K-type thermocouples, which I think are more commonly used on if you've ever had a multimeter that had a temperature sensor attachment. I believe
Mm-hmm.
those are the K-type thermocouples.
I do, but I'm a double E, so
There you go. But most commonly, Brew Troller and some of the Raspberry Pi type controllers like Brew Pi, they're using this Dallas 18B20, I think is the model number. It's a one wire. Which is a misnomer, but it's a one-wire sensor versus like the RTD sensors are a little bit different in how they're wired. And there's benefits either way. I think the RTDs are a little bit more, have a little bit finer grain detail in terms of the resolution of temperature than the Dallas ones, but they're a little more difficult maybe to set up, require a little more code in order to make them work, that kind of stuff.
And obviously you have a large number of controllers with a wide variety of capabilities, everything from a simple, thermistor or, even a pot, all the way up to a full-blown microcontroller. What are some of the variants?
Well, and I was just recently introduced to one that I didn't even know existed. So there is a variable solid-state relay technology that is very simple. So you use a pot, use this solid-state relay, and you can, in essence, vary the voltage directly. And those are inexpensive. They're very DIY friendly, very quick and easy to set up. And one of the guys in our local homebrew club has one, and he loves it. He says it's a great way to brew. From there, you kind of step up into your normal PID displays, which are simple controllers. So you can set a temperature and potentially a time. And typically on a PID display, you'll have two numbers, and you'll see your set point and
So
your
is this one
temperature.
here? This is
Yep, that's a
yeah.
PID, and so they will maintain a specific temperature, typically within a degree or two, whatever the setting is or the range is for that particular PID, and you can put multiples of those in a control panel if you're going to control multiple elements, and they're very approachable. They're easy to install. There's lots and lots of information out on the internet right now about how to wire those up, and they're a great option for someone who wants to approach a very simple way to homebrew, and still maintain that level of control, that being able to set a temperature. And
So what does PID stand for actually?
I never get it right. There's three values. A PID is, and I'm not even going to try it because I'm going to get it wrong. But there's three values that those three letters PID are three values that you can adjust those particular settings within the logic on the controller that adjust and control the amount of variation. So, as that element is trying to hit a certain temperature, it's going to go above the temperature a little and below the temperature a little and above the temperature, and it's kind of do that in a wave and that wave is going to get smaller and smaller and smaller until it gets to where it wants to.
I'm reliving my control theory class here.
Exactly. So, adjusting those PID values allows you to kind of minimize the bounce, and to really hone in on as precise of a temperature as you can possibly make it. Whether or not there's benefit in sub-degree resolution, I don't know. But the ability to be able to do that, or to be able to take one that's varying wildly because your system has some fluke to it that that the original designer didn't realize, but the ability to be able to control that is what a PID offers you. And most of the when you take a step above a PID and go to a microcontroller or PLC device, the PID logic exists inside of those devices as well.
Right.
So
we talk about a microcontroller. We actually talk about a little computer, right?
Exactly. So on the commercial level, and in the industrial world, you've got PLCs, programmable logic controllers, and those are something you can use. But in the homebrew world, what you're seeing more and more of are microcontrollers, small computers like the Arduino, which is what the Brew Troller is based off of, the Raspberry Pi, which is what BrewPi is based off of.
The Raspberry Pi is a very cheap Linux computer, I believe, right?
Exactly. Although there is a version of Windows that will run on it now, but primarily is Linux, and they're a fun toy to play with even outside of brewing. And then
I think they run under $20 now, don't they? Something like that.
I think you can get the A version for under $20, and they've actually released a new one, the B Plus, that is even more powerful. Which is it, but that's getting a little off topic. They're fun to play with. And then the BCS is another controller out there that is not based on Arduino or Raspberry Pi, but I think it's an ARM based microcontroller. So
you can use. Any single chip microcontroller probably could do the logic we're talking about here, right?
You could actually, in theory, I think LabVIEW has a module that you plug into your computer, and your computer acts as the brains of the setup, and the LabVIEW module is just the control, the gatekeeper, the traffic cop, you might say. So there's all kinds of options in terms of controllers. When you step into a microcontroller, what you get is the ability to take it beyond just simple temperature and set point. So you get the ability to get feedback, charting and logging, for example. You get connections to the internet, so you can control your device, your brewery via a phone or a computer or any number.
I can keep brewing while I'm at the pub, right?
In theory, you could. That's probably not the safest idea, but you could probably do it. But when you start getting into even the more advanced ones like BrewPi or Brew Troller or BCS, you can start to control things other than your heating elements. So pumps and valves. You can control pressure sensors for volume, so that it opens up to just a huge variety of things you can control other than just the heating element.
So if you're a control freak, you can probably set the whole thing up so it runs completely automated, right? You just push a button and it brews the beer, right?
Absolutely. I know guys that have built grain hoppers that sit on top of their mash tuns, and at the right time, a solenoid opens and it drops all the grain in. Guys have built hop droppers that you fill tubes with your various hop additions, and they just kind of slot around and just like an automatic fish feeder, and drop the hops in at the right time. So absolutely, with enough imagination, you could press a button, leave, come back to a full carboy, ready to go.
Sounds like a plan.
Takes all the fun out of it, I guess, maybe. But if you really like that,
I still enjoy sitting around the pot wait for the thing to boil, but that's just me.
And for me, brewing is a very social thing. So I rarely brew alone, although I do find when I do brew alone, the brew day goes faster and better. But it probably is a reduced
fewer mistakes too, right?
Yeah. But I love to have folks over. I love to have other folks that are brewing at the same time. And there's kind of an added benefit to electric brewing, and especially controlled brewing with a microcontroller, is it allows you to step away. You're not watching that mash tun, that gauge on your kettle to make sure it's at exactly the right temperature. You've set it, you've walked away, and for that 60-minute mash or that 90-minute mash you're going to do, other than maybe just checking in to make sure nothing's gone wrong, you can help another brewer learn to brew. You can open a great beer. You can. Don't
you still have to stir it a little bit? I mean, unless you got a recirculation pump, I guess.
Yeah, and
avoid hot spots and so on.
Exactly. So in a brew in a bag system, you're probably going to want to be stirring occasionally. With my HERMS system, for example, I don't want to stir because I want that grain bed to eventually set and get that crystal clear wort by the end of the mash.
Makes sense. We talked a little bit about controlling the heating element. What are some methods for doing that? You mentioned, let's see, you talked about using a solid state relay, for example.
Mm-hmm. Heating elements are most commonly controlled via a solid state relay. You could, in theory, control one with a mechanical relay. The reason that solid state relays are preferred is because of the volume of cycling on and off. So as I mentioned briefly, you're not changing the voltage to reduce the power of the element. You're actually cycling it off.
So, I mean, you think of it as you're turning the element on and off at a very rapid rate, right?
Very rapid rate. And so, if you're going to go 80% power on your element, it's off 20% of the time, on 80% of the time, but it's rapidly fluctuating that back and forth.
So you think about your electric stove, it'd be kind of like, pushing the buttons on your electric stove really quick.
Exactly. That's exactly right. And a mechanical relay would just eventually wear out. They're just not designed for that
Makes
volume.
Sense.
But the other ways you can control elements are like that variable solid state relay I mentioned, or what they call variarcs, or
varistors.
Exactly. So and those allow for controlling the actual voltage versus the pulse width modulation.
Right, which is also going to change the current and change the amount of heat it's putting out, right?
Yep. And heating elements in terms of voltage are not linear. So, if you take a varistor and you turn it down to 50%, you are not actually getting 50% of the power of that element. You're going to get a significant amount less at 50% actually. Mm-hmm. So I don't know the actual curve, but they are not linear. So that's something to be aware of if you're going to go that route, even with the variable solid state relay, that your level of control is going to be a little touchier. You can't just turn it down to 50% and expect I'm at half power.
I think it goes with V squared is what I remember from my old days, but don't quote me on that. So we also talked a little bit about pumps. A lot of electric systems include either a recirculation pump for mashing, or they have transfer pumps. What are some of the pump options, and how does the pumping work?
Well, pumping, using a pump is by far the biggest upgrade to my brewery that I've ever done in terms of just making my brew day more pleasant. And the options are, there are not a whole ton of options for pumps in the homebrew world. You've got your standard March pump, and then the chugger pump, which is becoming more and more popular. And there's some options in there in terms of the size of the pump, the size of the impeller, what the housing is made of. But all of those pumps share a specific feature, which is they're all magnetic drive pumps. And the benefit to that, and the reason you use a magnetic drive pump, is to avoid having any kind of a lubrication or non-food safe
So
materials.
this is a chugger pump, I believe.
Yeah, with a stainless head.
Mm-hmm.
And the mag drive pumps separate all of the lubrication and guts of the pump from your beer. The other options, and a little bit more expensive option, is a peristaltic pump. I have used a peristaltic pump on my setup, and it has its positives and negatives. The big positive is they are self-priming. March pumps and chugger pumps are not self-priming, which is not really that
big. So what does that mean, self-priming?
So a peristaltic pump, a self-priming pump, can literally pull liquid out of the vessel for you. So the pump can start dry and pull the liquid out and then move it into the next vessel. March pumps, you have to, or chugger pumps, you have to fill the head with liquid before they will pump. So they cannot suck liquid; they can only pump liquid that's being fed to them.
So how do you do that in a practical way?
The most practical way is to mount your pump as low as possible, but definitely lower than all of the vessels that you're going to be pumping into or out of. And on my setup, I've actually got a relief valve on the output that allows me to open that. So I can open the valve on whatever kettle, open this relief valve, and it lets the liquid flow through to completely fill the system before I go. And I've, in my experience, if you prime the pump that way one time and then never allow air to get back in, so you close your valves at the right times, you never have to worry about priming again for the rest of your brew day. Cool.
So, you got any other tips or considerations for picking a wort pump?
Well, there's a number of pumps on the market that are a kind of a smaller version of a March pump, or 12 volts. So what you need to do is determine how quickly you need liquid to move from one space to another, and that will kind of help you determine what you need to do. And then the other thing to consider is whether or not you care about using stainless steel in the pump heads. Those are kind of the two big feature sets in pumps right now, are size and stainless versus plastic, to put it very simply. I'm a big fan of stainless. I think it's great and easy to clean. I think it's less prone to cracking. You know, my brewery sits in the garage.
So here's, I think this is some of the March pumps here, right?
Mm-hmm.
What they look like.
And there's actually, I'll note that there's actually some upgrades kind of available. And if you have a March pump and you want to upgrade to a stainless head, and you've got a plastic one right now, chugger or March stainless heads will fit on your motor. But I know for the March pumps, you can actually purchase a bigger impeller, or the impeller from the next model up fits in the model down, the 809, and will actually improve your flow and make priming a little bit easier. And I know that was kind of a really popular upgrade. And it's only like maybe $15 or $20 to order the impeller. So an interesting little upgrade to kind of improve the efficiency of your system. I will also note from experience that if you're pumping through tubing, like silicone tubing or plastic tubing, your flow will be slower than if you are pumping through metal pipe or tube. So I've got a big chunk on my brewery. I've got two big stainless rails that run the length of my brew stand from my pump. And so that allows me to use really short silicone tubes to get up to my ball valves or whatever. And the increase in flow and speed at which I'm able to transfer liquid was dramatic over having the big, long silicone tubes going all over everywhere.
Makes a lot of sense. Yeah, you get a lot more resistance with the silicone, I would imagine.
Yeah, no doubt. It's a little more costly to install hard tubing. And you do got to take a little more care in cleaning because it's not as removable. But pump a little bit of PBW through it and clear water, and you're really fine. And I think the benefits outweigh any of the negatives.
So that brings up the next topic I want to discuss, which is how do you clean out your pumps and your tubes if you have a system like this?
I'll use my brew day as an example. So once I get to the point where I'm boiling, I clean out my mash tun and get all of the grain out, of course. And then I fill my hot liquor tank with water and the appropriate amount of PBW and heat it to about 140 degrees, which is a great 140 to 160 degrees, which is a great temperature for that particular cleaner to do its job. And then at that point, once I'm done with the boil, I can have already cleaned out the mash tun. Although I typically tend to wait because I don't want to have to rinse some of the recirculation tubing. But I finish my boil, and then I can pump that PBW through every fitting, through every valve, and through every pump. And I'll typically let it run from one vessel to the other, and then recirculate inside that vessel for 10 or 15 minutes per vessel, and that does a really good job of cleaning out all the tubing, cleaning out all the pumps, and then I run clear water through everything. I don't typically have to wait as long to run clear water through, but I run the clear water through, and then I open all the fittings and let everything dry out. So it's really not difficult, and in fact, with some of the controllers, you can actually program a clean mode that will do. You can even do the cleanup automatically. Just
if you get an all-in-one, huh?
Yeah, you're really good. So I know some guys that do that. In fact, some guys even just program a recipe that does nothing but move the liquid around to the right spot.
Just you have your robot arm drop the PBW in, right?
I think that's a great idea.
Okay. Well, we talked about using a microcontroller for temperature control, and we talked a little bit about using it all in one. Obviously, you get a lot of advantages if you have an all-in-one controller, right? And a fully automated system like this.
Absolutely. The advantages really are in the level of control. The only real disadvantage would be cost, but even cost isn't that much more significant over, if you wanted to control 3 heating elements, by the time you buy three PIDs and all the solid state relays and everything you need, you're really not saving a whole bunch of money over buying a full-fledged controller. And now you get to add a whole lot more control. And I think, as I'm seeing the industry move forward, a level of control that puts the brewer in control where the brewer wants to be in control.
Yeah, I mean, a lot of these microcontrollers are under certainly under $100 and well under $50 in many cases, right?
At least for the basic ones. I think you can start, the Brew Pi that they recommend or the Raspberry Pi they recommend for the Brew Pi project is, I think, the most you're going to spend is $39.99 for that thing, and you could start working on it. You can spend a whole lot more. Blickman's Tower of Power can get a little bit pricey.
He makes some nice stuff, though.
Yeah. Oh, they're and I'll tell you what, they're some of the most well designed in terms of looks. I mean, there's nothing quite like 3 Boilermakers sitting there with 2 Tower of Powers and all of the kit and caboodle. It's pretty
John's
impressive.
a very good friend of mine.
Yeah. Yeah. One of the guys in our club brought his whole Blickman setup to Big Brew Day in May, and he had 3 Boilermakers on 3 burners. Well, I guess technically only 2 burners and 2 towers of power. And to watch that thing run was just really impressive.
Yeah. It's really nice stuff.
Yeah. So,
well, you have a new controller you're working on at brewtroller.com. I'll bring up the website there. Brew Troller, BREWTROLLER.com. Can you tell us a little bit about what you're doing?
Well, certainly, and I'll first point out that Brew Troller is not actually new. It's been around for quite a while, a number of years now. But the project.
I was just noting you got a Kickstarter campaign, for example.
Yep, exactly. The project kind of stalled, and it was really around the original owners of the project needed to focus on some other things, and they very graciously agreed to let me take over and kind of do some of the things that I had envisioned, which were really focused around the interface. But Brew Troller is an Arduino-based controller, and in order to bring it back to market,
what does that mean for folks that may not be familiar?
So Arduino is an even smaller computer than the Raspberry Pi, and it's actually less of a computer and more of a device that does very specific things, right? It's not the kind of thing you're going to plug a monitor and a keyboard in and surf the internet. But Arduino was originally designed to be kind of a learning tool for folks that wanted to understand how microcontrollers work. So one of the first things you learn to do with an Arduino is plug an LED in and make it blink. And so Arduino does a great job of connecting the user with hardware and software, so you kind of understand both sides of it. So Brew Troller started because a bunch of guys knew Arduino and thought, hey, we could probably brew beer with this and kind of make it neat. And it's progressed, through many iterations to where it is now. It's now a custom circuit board. It's not an off-the-shelf Arduino. And the benefit there is that it's got all of the extra components that you would have had to have purchased and figure out how to wire in already right there on the board, including internet capabilities, including all of your buses for temperature probes and RS-485 and all of these other communications protocols.
So is this a picture you sent me then?
Yep.
The one with the controller? I'm trying to bring up let's see, there it is right there.
That circuit board that's the last model that was being made by the old owners. And what we're doing with the Kickstarter is we're taking that from the way they were doing it, and he was doing it locally by hand. They were an amazing product. Quality was fantastic. We're moving it into a manufactured situation with actually a manufacturer local here in Central Illinois, and trying to make this thing go bigger. And we've got all kinds of course, future plans for it. But in order to take that step, we needed a Kickstarter because we needed help to kind of push that off. And I'll tell you what's really kind of shocked me is the demand as we've taken over and kind of talked to the user base that already exists and folks that were interested in this already about what we're doing. A lot of folks don't want to see this thing go away. And so I was very excited to kind of be a part of making sure that didn't happen.
Now, unfortunately, I think by the time this thing plays, the Kickstarter may be over. You're closing it out about the end of June, if I recall.
Right.
We're recording this fairly close to that. But you do have your Kickstarter campaign going right there.
Yeah.
And looking to raise some money. And so have you got a prototype of the new system yet?
Well, I've got a couple locally, here, of course, that we've built. I'm actually using an older version in my brewery right now, and then we're installing for that buddy that's actually doing the big 145-gallon system. He's starting a microbrewery, a nanobrewery, and we are piloting the kind of the newest version of Brew Troller and all the software around it in his brewery. So those are our current pilot kind of models. And the benefit of the way we've done this is since this product has existed already, we didn't have to do a whole lot of design or change around that. So we know the product is solid. We know it works beautifully. We just want to make it as approachable to the average user as we possibly can. So
what are the overall capabilities? Is this something that could control the whole system from start to finish?
Absolutely. In fact, there was, unfortunately, the gentleman that did this sold it and built another one similar, but he actually built a 2-vessel RIMS system that was push a button and literally everything happened. This truly is an all-in-one controller, and not only can it do that, but it can... The web interface that we're working on enhancing right now is one that is, I think, going to be top tier in the industry in terms of allowing a user to connect to their brewery in whatever way they want to. So I've been a web application developer for a long time, and one of the things that I always find to be important, and I think lacking in the web world right now, is that you need to meet the user where the user wants to be. So I shouldn't have to define to you, the brewer, how you want to brew and what technology you want to use to do that with. I should be able to take my system and my technology and just enable you to use whatever tablet, device, phone, computer, television, whatever it is you want to do, however you want to interface with it, I want you to be able to do that the way you choose.
Cool. So, we probably eventually pass recipes using something like BeerXML, right?
Absolutely. In fact, right now we can already do that. So if you go into BeerSmith, which I use to create all of my recipes,
of
course, and export to BeerXML, I can directly import into my brewery right now as long as it's connected to the internet. That's an automatic. That's easy. It works beautifully, and then you can store up to 20 recipes right on the brewery itself.
Right. BeerXML is a standard format. BeerXML.com, exactly. Standard format for exchanging recipe data, actually.
Exactly.
And BeerSmith supports a whole bunch of other applications do as well.
And it works beautifully. And you can enter recipes directly on the Brew Troller, literally directly on the control panel. So there's a small LCD that you mount in your control panel, and an encoder, a rotary encoder, which is very similar to the way the old iPods used to work with the dial and click.
Sure.
You can create a recipe literally on the controller that way, but it's a little cumbersome. It's not bad, and I've done it many times. But the ability to be able to go into something like BeerSmith, create your recipe, and be able to see the parameters change in the way that BeerSmith allows you to do, and then just be able to export that puppy right out, import it into your brewery, and start your brew day. That's a perfect example of what I'm talking about, being able to meet the user where they want to be doing their work. Make it easy, make it so they can interface with the technologies they're already using, BeerSmith, and make the entire experience pleasant.
Mm-hmm. Yeah, and eventually maybe we can interface it with the cloud too, which would be kind of cool. Make it really easy.
Absolutely. The easier we can make it, and again, the closer we can get to wherever the user wants to be, the better.
Yeah. Well, Adam, I wanted to ask you, is there anything else you'd like to add?
Well, whether or not this makes it out before the end of the Kickstarter, I'd encourage folks to participate in this community, whether it's whether it's purchasing or backing a Kickstarter, whether it's being involved in forums or user communities that exist out there around brewing. I encourage you guys that are listening to this to go out and participate in these communities, because when you look at folks like me that run Brew Troller, or Brad, you and BeerSmith, or any of the other kind of technologies.
Yeah, I'm a one-man show here.
Exactly. We need you guys to not only help. There's some amazing folks that have stepped up to help with development and software and so on and so forth for Brew Troller, but we need ideas. We need your feedback. We can't live in a void and provide the type of technology that you guys want. So there's a bunch of small businesses, one-man shows, two-man shows that are out there trying to provide the home brewing community with the things that they want. And the only way we're going to deliver it the way you want it is if you participate. And so that's really the thing I want to add. I want every home brewer to be a part of a club, to be a part of a forum, to be a part of a user group in the area that is actively involved in home brewing and advancing the craft and being a part of seeing where home brewing can go in the future.
Fantastic, Adam. Well, thank you.
Mm-hmm. Thank you.
It's great having you on the show. Thank you, Adam. My guest today was Adam Shake. He joins me from BrewTroller.com. Adam's been brewing for more than 12 years and is currently president of the AB Normal Homebrewers Club. You can find out more about his latest project at BrewTroller.com. Thanks again, Adam.
Thank you.
Thanks again to Adam Shake for joining me this week. Thanks also to Craft Beer and Brewing Magazine, where you get your 15% discount on their magazine or anything in their store if you use the offer code BeerSmith2015 when you shop at beerandbrewing.com. Again, use the offer code BeerSmith2015 and get your subscription now at beerandbrewing.com. And also, BeerSmith Mobile, the perfect brewing app for your iPhone, iPad, Android, or Kindle Fire device. Learn more about creating great beer recipes with BeerSmith Mobile at beersmith.com/mobile or on Google Play, iTunes, or the Kindle App Store. Thank you for listening. I hope you have a great brewing week.